All right. Here we go. I'm kind of making this up as I go because I need to figure out a way to record. All right, so try that. We'll see if that works. Cool. So this is going to be using the stuff that we did on Thursday. We're going to take one function and put it inside the other one. Remember, this means f of g of x. And we're going to take g of x and put it inside f of x. So we're going to take our f of x, that 3 times something, and in place of the parentheses, we're putting that g of x function, that 5x squared minus 2. So we're taking the g of x and putting it in place of this x right here. We're substituting it in, combining them together. So in order to simplify this, what do we need to do? How do I simplify this right-hand side? Distribute. So I'm going to distribute the 3, and we're going to have that f of g of x is 15x squared minus 6. The right-hand side is very similar. It's just going the other direction. So instead of f of g of x, this one is g of f of x. And PowerPoint is significantly grumpier with the amount of color changes that I like to do. So we're going to be very kind of monotone on this one because otherwise it gets grumpy at me. So we're going to take our g of x and we're going to put in place of this x here my 3x squared minus 2. You know, when I stand on the left hand side, my handwriting gets so much worse. And then we need to simplify this. Order of operations says we do what first? The exponent. So I can't simplify anything in the parentheses. So then we're going to go out. I need my exponent next. So I need to do my 3x squared before I multiply that 5. So this is going to be 5 times 9x squared minus 2. 5 times 9x squared is what? 45x squared minus 2. So we can really see here that it matters which one's in front. G of f of x versus f of g of x. So the order is really important. Questions on this last bell work from last week? I love that for myself. It's just been one of those days. Oh my gosh. So when you leave today, if you could turn in that bell work, I will get the bell work adjusted for this week, but it just didn't make sense to move on to the next bell work because it doesn't make any sense to what we're doing. So we're trying again. So turn that in if you have not yet done so on your way out today. So we're going to move on with the next piece of this chapter, which means we're going to have another definition. So what we're going to do today is we're going to work with inverses. And we're going to work with inverses a lot this semester. The top little paragraph up here, that's what's in the book, which is all well and good, but they overcomplicate stuff sometimes. So this is how I do it down here, and I feel like this makes more sense once we get into it. We're going to find our two variables. I'm going to find my x. That is not what I meant. There we go. I'm going to find my y. And what it feels like, it's very Mad Hatter from Alice in Wonderland, where they change places. And they're physically going to change places. So when we are finding our inverse relations, our inverse functions, we're going to be taking our x, taking our y, and changing their places. No numbers get changed in the process of making the inverse. We have worked with inverse operations for years and years and years, whether or not we use that word. The fact that adding and subtracting undo each other. Those are inverse operations. Multiplication and division, they undo each other. Those are inverse operations. Squaring and square roots are inverse operations. So what we're going to be doing is we're going to be taking specific equations and finding something that will undo it entirely. So they are inverse operations. They are related. The other important piece on this page is to grab this notation down here at the bottom. This is how we say, this is not just a brand new function. This is a special function that is related to the one you gave. This notation means the inverse function. So if we start with f of x, we get f to the minus 1 of x. We read that as the inverse of f or f inverse of x. I don't care how you word it. But it's the inverse function. So what we're going to do, our process for this is to take the x, take the y, change places. Take the x, take the y, change places. I'm going to say that enough times today, you're going to get real annoyed. And we'll talk through it, I promise. But we're going to find the x, find the y, and make them change places. Nothing else is going to change in the inverse step. Okay. So our first function that we're going to use is this. We're going to have f of x is the set of points. That's what the squiggly bracket means. It just means the set of points. These points and not anything that connects them, just these dots. 1, 2, 10, 11, 0, 3, and 9, 7. Yes, I think you should write these points down. Because what we're going to do is we're going to take our points, remembering that our points are made up of x, comma, y. And what we're going to do is we're going to take our x and our y and make them change places. That is how we make the inverse. I'm going to take my x, I'm going to take my y, and they're going to change places. So for each of these individual points, I'm going to take my x, I'm going to take my y, and I'm going to make them change places. So what was my x becomes my y, and what was my y becomes my x. So 1, 2, when we take the inverse, becomes 2, 1. Physically change places. And we're going to look at the next point. Again, I have an x and I have a y. So I'm going to take my x, I'm going to take my y, and they're going to change places. So 10, 11 becomes 11, 10. X, I have a y. Well, 0, 3 becomes 3, 0. How about this last one? 9, 7 is going to become what?
7, 9.
7, 9. Not super complicated. So we have this new function. That's a set of points. So I'm going to put my squiggly brackets on them. And then I'm going to name it. It's not f of x, so I'm not just going to call it f of x again, because they're not the same. But they are related. This is the inverse of x, or inverse of f. So we're going to say this is f to the minus 1 of x. That's what its notation means. It is the inverse function of f. It is the inverse function of f. Questions in our first set of inverse. I feel like starting with points, it's not awful. We're going to do one more with points. This time it's g of x. Process doesn't change just because he's got a different name. We're just remembering that g of x just means that this has got a different suit on. It's still y, it's just a different suit. So to find our inverse function, we're going to take our x and our y and make them change places. So 4, 1 becomes 1, 4. 5, 0 becomes 0, 5. My x and my y change places. 13, 9 becomes 9, 13. And 12, 10 becomes 10, 12. The only thing different on this one is that was weird. Is that, oh great, and now it's not going to let me erase either. So we're going to do a chunky Algebra again. Is that this isn't called f of x. This is called g of x. So when we want to say this is the inverse, I can't say it's the inverse of f. Because it's not. It's the inverse of g. The only thing different on here is instead of putting f to the minus 1, I'm going to put g to the minus 1 of x. Just because he's named g. He's not named f. It's like Fred and George. It's just a different name. So it doesn't change what we do. It's just changed how it's named. So if it has a different letter, when you're putting it in your function notation, you use that other letter. Everything else stays the same. Questions on this one? Because it's going to kick up a notch. Because now we're not going to deal with a list of points. We're going to deal with an equation. So we're going to use an equation, and we're going to find the inverse. So we have f of x equals 3x plus 2. So just like we did on the points where we took our x and we took our y and we had them change places, that's what we're going to do here. But I don't have a y. But if we remember that f of x is just y dressed up in disguise. That's what my first step is going to be. I'm going to take my function notation and switch it back into our algebraic notation. So I'm going to take f of x and make it y again. So f of x is 3x plus 2 is the same exact thing as y equals 3x plus 2. From here, we're going to do exactly like we did in our points. I'm going to take my x, I'm going to take my y, and they're going to change places. So I'm going to take literally just the letters, just the x, just the y, and they are going to change places. This is the step that makes the inverse. It's going to become x equals 3y plus 2. Just the letters change places. No numbers move, no numbers change. This is the step that makes the inverse. It is the inverse now. Like, that's the mathy step. It is just really, really bad math grammar now. Because now it's an x equals instead of a y equals. And that kind of makes our eyes twitch a little bit. Because what can we do with an x equals? Not much. So now all we need to do is we need to solve this for y to put it back into our proper math grammar. What do I need to do to get y by itself here? Subtract 2. So I'm going to subtract 2 from both sides. Whatever I do to one side, I do to the other. We get 3y equals x minus 2. Y is not quite by himself though yet. So what do we need to do?
Divide by 3.
Divide by 3. So we're going to have x minus 2 divided by 3 equals y. Woohoo!